In this question, you are asked to find the range of values of m such that y equals 3mx squared plus 6x plus m is always positive. Now, this is a typical question on quadratic. Let's take a look at the graph here. So, for ax squared plus bx plus c equals 0, the discriminant d is equal to b squared minus 4ac. And students are actually tested on the understanding of what the discriminant means. So if you look at b squared minus 4ac, if it's greater than 0, there are obviously two real and distinct roots, and the curve will cut the x-axis at 2 points, regardless of whether a is greater than 0 or a is less than 0. If the discriminant is equal to 0, there are two real and equal roots, and the graph will cut the x-axis at one distinct point. If the discriminant is less than 0, the roots are not real, or you call it imaginary, and the curve will lie either above the x-axis or lies below the x-axis. So let's take a look at the question again. You are asked to find the range of values of m such that y is always positive. So that means the graph must lie above the x-axis, and that implies b squared minus 4ac must be less than 0, and that is what we want. So let's work it out. So for a greater than 0 and b squared minus 4ac less than 0, we know that b is equal to 6 and a is 3m and c is m. So we have 6 squared minus 4 times 3m times m less than 0. So work it out, we get 36 minus 12m squared is less than 0, and hence m squared is greater than 3. And if we plot the graph, m squared actually has got a u-curve, and it cuts the x-axis at 2 points, square root 3 and minus square root 3. And if we want m squared to be greater than 3, m has to be greater than square root 3, or m has to be less than minus square root 3. So since a is greater than 0, 3m must be greater than 0. Therefore m cannot be less than minus square root 3, and hence the answer is that m is greater than square root 3.